Hi, Dr. Mamari again, and I'm going to perform experiment 3. Experiment 3 of the laboratory manual that is designed and published only for Central Campus. You will buy the ebook from Vital Source for Remote Learning Lab, and the experiment 3. The purpose for this video is to provide you data for your experiment, so you could turn in the data sheet, pre-lab questions. It would be another assignment that you're going to either take as a quiz or turn in the assignment to the assignment folder by studying the chapter itself, the experiment 3 part theory and explanation that comes with the experiment. We are going to perform experiments regarding empirical formula. What is empirical formula? Empirical formula is the lowest whole number ratio of the elements in compound. And so when you read this theory, you learn about the empirical formula. How would you calculate the empirical formula? You need to have the mass for each of the elements in the compound. When you have the mass for each element in the compound, then use the periodic table to find the atomic mass, to convert the mass for each element to number of moles for each element. When you have the moles for each element, then you have mole ratio. To find the lowest ratio, you divide both numbers or all numbers. If you have more than 2 elements, you divide by the lowest number of moles. I understand that by explaining this way, it might be a little too fast for you, but when you study this experiment, the theory of the experiment, you will get it and also listen to the video. So you find the number of moles for each element, you divide all of them by the lowest mole number. That gives you the lowest ratio. Lowest ratio is not sufficient for empirical formula. You have to have the whole number lowest ratio. So in order to get the whole number for lowest ratio, sometimes you have to multiply by a fixed number. Let's say if you get a 0.5 for one of your number of moles, you multiply everything by 2, then that 0.5 would change to 2, because fraction or decimal is not allowed in the empirical formula. It has to be whole number, but lowest ratio. So you will have to get the calculation following the instruction that is showing in the calculation part. We have the definitions for empirical formula, the purpose we are doing this experiment, all of that is explained. So you could find the mass ratio for practical purposes. You will find the mole ratio. We find, by performing this experiment, we are going to find the empirical formula, and we also are going to study the kind of the law for conservation of the mass, to see how much of the mass of the product we get at the end of the zinc iodide. Then the compound that we are going to study is zinc iodide. So I am going to actually start the procedure for the experiment, and for you to collect your data. Make sure to study the first 3 pages in order to be able to answer the pre-lab questions and perform the experiment, or watch the experiment to collect your data, and then you will turn in your pre-lab and your data sheet after you complete using the instructions and the data collected for today's lab as a result of today's lab. Okay, I'm going to start with the procedure for the experiment. Procedure for this experiment 3. First, we are going to start with measuring the mass of, let me just follow the procedure step by step, because you are going to have access to this procedure when you purchase your lab manual online, the ebook for the lab manual. So we are going to first heat up the evaporating dish we're using a Bunsen burner. We are going to heat up the evaporating dish to get a fixed mass, because if there is any extra volatile compound or moisture on the evaporating dish, it's not going to be the same as if it was completely clean and dry. So in order to remove anything excess from the evaporating dish, we are going to fire the evaporating dish on Bunsen burner. So I'm going to turn on the Bunsen burner first. To turn on the Bunsen burner, you have three separate valves that you have to adjust it. One is the main gas valve adjustment here that you can open. It depends on how high you want the height of the. There's a gas adjustment for this knob on the right side. You have the gas adjustment, and you're going to just righty-tighty and then left the loosey. So you are going to rotate to the left side to open it, and right side to close it. So you are going to open the gas valve, and also air valve adjustment. So by moving the cylinder, you have to hold on to the cylinder in order to again righty-tighty, lefty-loosey to the left side, and you are going to see this opening here. It gets increased, more air is going to come through. What is the benefit of adjusting this? Then you are going to get proper ratio of gas, oxygen, so the natural gas, which is the organic compound, and then the oxygen. The oxygen is provided from the air. The gas is coming from the gas valve here. So if the ratio is not proper, what's going to happen? If I'm going to show you what's going to happen so you could see it better. If I turn on the gas, if I turn on the Bunsen burner, I should have stopped, make sure everything is working before I keep striking. It's like 2 times, 3 times strike, it doesn't turn on. You have to make sure your adjustment, make sure the gas is open, the air, some air is allowed. The striker is working. When you try the striker, you should see a spark here. Sometimes by moving it up and sliding, you don't create any spark, so it's not working. So striker could be working and you don't know how to work with the striker. So basically you have to press it down, this movable piece, press it down and slide so you could create the spark. That could be one problem that you cannot turn on the Bunsen burners, because if you're not engaging, there is no spark being created here. When the Bunsen burner turns on, what type of flame we like to have is the blue color, 2 or 3 cone. We don't want this yellow color. Yellow color means incomplete combustion. And when you have incomplete combustion, that means the air is not enough. If you don't have enough air, the result of the chemical reaction of a combustion reaction of the gas, the product gives products of carbon dioxide and water. But if you don't provide enough oxygen, it's giving off carbon monoxide. The yellow color and some smoke that is coming to the edge, that's actually producing carbon monoxide. 2 problem, carbon monoxide is toxic. We don't want to have it in the lab and inhale it. Second problem is that the flame is not hot enough. So how to take care of that problem? You have to provide more oxygen. To provide more oxygen, you are going to rotate the cylinder to the left side until you get enough gas. You see the 2 cones here on the flame. You have the darker and lighter blue color of the cones. Now you have perfect flame. So you are going to use a crucible tongue, hold your evaporating dish over the flame. Try to heat it up to evaporate any water that is in the evaporating dish. This container dried. We haven't used them for a long time. I just want to make sure to show you the technique and how to use this. So when it's done, when I heat it long enough that the water evaporated, now I have to place it on the surface in order to get the evaporating dish cool down to room temperature. So I'm going to leave it on this base that is clean. I can use a wire gauze also to hold it on, to place it on a wire gauze. So can leave this on a wire gauze to allow it to cool down before I can measure the mass. Okay? So I'm going to let it cool down before I measure the mass. I don't need the flame for a while, so I'm going to uh, turn off the Bunsen burner. When you need it, I come back and turn it on again. Okay. I need about 0.5 grams of zinc. While it's cooling off, I'm measuring the 0.5 grams, and I will be using it soon. So 0.5 grams of the zinc. As you saw for experiment 1, I'm going to measure this indirectly. We have a chemical that you want to measure the mass. So I place the main paper, just explaining you one more time how we did that for experiment 1. Vein paper, press the tear button to tear to get the mass of the vein paper 0. Then I can add the 0.5 grams. Too much. The mass is 0.500. It does fluctuate, but the most stable number is a 0.500. It goes from 0.499 to 0.500. And since the report, the data sheet asks for the mass of the crucible and then mass of the crucible with the evaporating dish and the zinc, we are going to follow that format. So don't have to figure out those numbers and change them. So mass of the empty evaporating dish. Before I place that, I'm just going to make sure it's 0 again. Place the evaporating dish. Record the mass. The mass for evaporating dish is 40.259, 40.259, and that is for A. I'm going to add 0.5 grams of zinc. B is 40.759 grams. Then we have mass of the iodine, stoppered iodine. Mass of the stoppered iodine. So I'm going to take this out. Have those. Because it's a test tube, I'm going to place the test tube on the inside a beaker to measure the mass. So I don't have to lay it down, even though it's stoppered already, but still it's the correct way. If you have a test tube, it's better to have a container to place the test tube in, but you don't need the mass of the beaker, so you just leave the test tube inside a beaker. So we have 12.172. 0.72, and that is C. Okay, so 12.172 gram, that is the mass for stoppered test tube. Then we're going to follow the procedure. We have the masses already recorded. We are going to take it to the fume hood. We are going to take the evaporating dish to fume hood. We add water and the acetic acid. Take the evaporating dish to fume hood. I'm going to take the computer so you can see what I'm doing inside the fume hood. So we place the evaporating dish inside the fume hood. We add 5 milliliters of deionized water. Three drops of 6 molar acetic acid following the procedure. And I add the iodine to the evaporating dish. So I have the evaporating dish with the zinc and iodine is reacting. See that iodine has dissolved and slowly is going to react with the zinc and produces zinc iodide. How do I know the reaction is complete or I can stop? I have to make sure that iodine, the way the experiment was designed, iodine is the limiting reactant, zinc is the excess compound. So we should have excess amount of the zinc left over, and all of the iodine needs to be consumed. One evidence for iodine to be consumed entirely is if the yellow color goes away and it changes to clear color. So until the yellow color is in, we are not sure that there is still some leftover of the iodine. So it's going to get more brown before it gets colorless because the iodine that is here now is reacting. So it's dark color. I'm going to leave it in the fume hood and I have to mix it. I have to make sure that the reaction is complete and enhanced by mixing it to make it faster. And sometimes it's just the matter of time, how long it takes for this reaction to take place. The reaction must be done in the fume hood because iodine is toxic and we cannot have it outside of the fume hood. So sometimes it takes 15 minutes just mixing it. Sometimes it takes less. It depends on how much extra of the iodine, how much of the iodine we have. Okay. I'm going to leave this in the fume hood and you can go ahead and measure mass of the empty test tube. That is the mass of empty stopper test tube. Because it takes time, you can use the time efficiently and finish some of the other work while we are waiting. So that's the empty test tube. I placed the empty test tube on the balance on the scale 11.727, and that goes for D. Okay. So we have the mass of the iodine to begin to start for starting a reaction. We have the mass of the zinc that we started the reaction with. And we add the water, we add the acetic acid, the reaction is going on. It might take 10 to 15 minutes. The dark color has to disappear and it should go to colorless solution. If it's colorless, completely colorless, that is the ideal. That is ideal. Okay. For the step 12 of this experiment is asking me to decant it into another to a beaker. I have extra evaporating dish, and I'm going to directly, because then it needs to be transferred to evaporating dish. So I'm just going to get the mass of the evaporating dish and fire the second evaporating dish. So when I'm decanting, I can decant directly into evaporating dish. If the supply is limited and we don't have enough evaporating dish to give 2 per group, then we decant into a beaker, and then we will transfer later on to the evaporating dish after the first part of part 1 of the experiment is done. But sometimes if we have enough supply and we read ahead and we are prepared to do the experiment, then we can combine 2 steps. We can actually be more efficient. So I'm going to fire the second evaporating dish while we are waiting for yellow color to disappear or for iodine to react with the zinc completely. So I can actually use the time and prepare equipment and chemicals for part 2 of the experiment. Okay. I hope you understand the firing part, the firing of evaporating dish, just to remove anything that is volatile, anything that is going to affect the mass later, because if we don't do that, and you see this brown spots here, if the mass is not stable, if let's say you have a paper there, you measure the mass later on after you heat up this for a long time, is going to burn the paper, and the mass gets down lower, and it's going to cause error, experimental error. Okay, it's heated. We wait for it to cool down to room temperature. Cool down to room temperature before I can measure the mass for second evaporating dish, and that goes actually for part 2 of the experiment. it's too hot. Even if I get this close to the evaporating dish, I can feel the radiation of the heat. So it's too hot. We have to wait until it's cool down to room temperature before we can measure the mass. So while we are waiting for evaporating dish to cool down, we can come back here and make sure that we mix the zinc with iodine, trying to get it to react faster. So it's very dark color now, and this dark color should disappear. It should get very light for us to make sure that the reaction is complete. For constant mixing, it's going to help the reaction to be to take place faster, but the time is a little bit more. Time is more significant, so we have to allow time for the reaction. So mixing is a factor, but time is the primary factor for the reaction to take place. So the evaporating dish that we have here is cooled down to room temperature. I can bring to my hand like very close to it, and it's not. I don't want to touch it because I don't want to leave any residue of oil on it from my hand. So we can make this 0, and the balance has to be here. Make it 0, and after it's 0, I place the evaporating dish. Record the mass. This is for part 2A.
Should I move or?
45981 grams. So this is the mass for evaporating dish for part 2 of the experiment. Okay. Okay, so we have the mass for the evaporating dish for part 2 of the experiment. What's time now? Time for checking on the zinc iodide reaction. Hopefully is somewhat done, or at least lighter color. I'm taking you back and forth because I'm working just by myself. Usually when you are in the lab, you work in group of 2 and you can share the work. But for me to do the experiment by myself, and I want to make sure that you actually get to see every step. So you're not just working with data, you're actually watching the experiment, just like if your lab partner was doing this part of the experiment and you were recording data and doing other part of the experiment. So you get better experience with the remote lab. Okay. It's still too dark. Too dark. The reaction is not complete. You can see that. And I'm going to give more time for this reaction to take place. It's better always to read the experiment completely, understand the procedure before you come to the lab so you can actually use the time more efficiently, and you would go prepare equipment and chemicals for the next steps. So I have all the iodine dissolved but not reacted yet. Is reacting. Gonna leave it here. Go and do another part of the experiment because it takes more time for this reaction to be complete. So what can we do for the rest of the experiment? We can actually prepare the equipment because the chemicals are engaged. Chemicals are in the other. So trying to find some. At one point of this experiment, I have to use gravity filtration. So I'm going to prepare gravity filtration apparatus for this experiment. And for the gravity filtration, we need a glass funnel. When you have a mixture of solid, and when do you use the filtration? Filtration is used when you have a mixture of solid and liquid. There are two ways to separate the mixture of solid and liquid. One would be decanting, and the second part is filtration. So you could do decanting and filtration. With the mixture of the solid and liquid that we have for this experiment, I think the procedure calls for decanting. We could replace it with the filtration, or if the procedure is asking to dry it in the zinc in the evaporating dish, then we have to decant it. So I'm showing you how to prepare the gravity filtration apparatus because we use it for another part of the experiment that I missed it for experiment 2 anyway. So that is the gravity filtration. Just leave it there in case we need to use it. So I'm using the time to prepare for next steps. And also, I need to evaporate the liquid. When we get the solution contains zinc iodide. The solution contains zinc iodide, and the solid that is left in the evaporating dish is going to be excess of zinc. The solution portion needs to be evaporated. The solvent evaporates, so what is left would be powder, like a white powder of zinc iodide. That is the product that we are going to recover for part 2 of the experiment. And the zinc that is left over, we are going to dry it using heating lamp and measure the mass again in order to find how much of zinc was left as unreacted zinc. So I have my Bunsen burner set up. To set up the Bunsen burner, I use an iron ring here to support the wire gauze, because later on I'm going to place my evaporating dish on the wire gauze. So there's something to support it, because I cannot depend on this. It's more safer if I'm using a wire gauze, or sometimes we could use like clay, a triangle is another equipment that we could use, but wire gauze is more secure. It's important for us to know the height of the flame and the height or the level of the ironing. If I leave the ironing all the way up here and the flame is all the way down, it's going to take much longer time for liquid to evaporate, for the solvent to evaporate. So I try to adjust the height of the flame as like a 2 inches. The iron ring, it should be about 2 inches higher than, the base of the flame or tip of the Bunsen burner cylinder. So that's how the Bunsen burner is set up when you are using the wire gauze. Sometimes you make like hot water bath, like we did for experiment 1 for boiling point. Sometimes you have to heat up any container supporting the wire gauze, so you know how to set up Bunsen burner for heating up. The other equipment that we are going to use today is the heating lamp. The heating lamp is just a heating lamp. It generates lots of heat that it can dry and evaporate the water or moisture from our product. So I have the heating lamp also ready to go here. When we get the zinc separated from the solution by decanting or filtration, we are going to place it underneath the heating lamp and evaporate it. To clean this so it doesn't get stuck to the bottom of the evaporating dish before I use it. So my equipments are ready for the next step, but I need to check and make sure the chemical reaction is taking place. This is a long reaction. It takes very long time. It's a slow reaction because it's just the aqueous solution. But the good thing is that it works, and it has worked in the past. If we put excess amount of the zinc, it will react with all of the iodine, and the reaction will be complete. With the evidence that the color of iodine disappears, that means all iodine has been used. Okay, I don't know, we can recognize using the color. Now it is lighter brown, but still it's too dark for us to stop the reaction. Just taking break. Just taking break of that. And look into the procedure. It's going to be a while because it's still too dark. I'm going to give some time and go back and mix it again. So based on the procedure today, we are going to decant in order to separate the zinc from the solution. So we are not going to use the gravity filtration for this experiment, but I'm going to use it for something else that part of experiment 2. Okay, probably at this point we need to be encouraged and at least have hope that is happening is much lighter yellow color, lighter brown color. I'm using Blackboard Collaborate for recording. There is no option for pause, and that's why you have to just wait here. If there was an option for pause, I would have put the recording on pause and then start recording. But if I stop recording and start recording, then it's going to be like 2 or 3 more videos. So I cannot pause that. So I just want to have one video for it. It's going to be longer video because we have to wait, but that's the reality. This part of this experiment is designed for like 2 labs, the 2 hours. And the challenging part of it is to get these reactions to be complete. But much lighter color of the iodide, almost done. But you could see that there's some leftover of the zinc. So we are going to have leftover of the zinc for sure in this reaction. And all of the iodine needs to be consumed for complete reaction. And if we don't be patient and we don't get the iodine to be consumed in the reaction, later on is going to cause error for your calculation. So the mass of the iodide that you use actually, because you are going to get the mass of the iodide using the balance, not the reaction initial mass that whatever iodine you use is expected to be dissolved and it's expected to be reacting. And if you take it while it stays yellow and decant it, some unreacted iodine will go into the decanted solution, the clear solution, and the mass that you're going to get is not the mass of zinc iodide. It would be the mass of zinc iodide plus unreacted iodine, which is not going to give you correct number, and be wondering why the numbers don't work. How come you're not getting straightforward numbers like they give you in lecture, and all of that. And that goes back to who actually did the experiment. If you were patient, you actually waited for the yellow color to disappear, or you just rushed through the experiment. You see the color is disappearing, and I was hoping that this will happen. So it means the reaction is working. Okay? This is working. Okay. I collected some drops of the solution here by placing my stirring rod in there. So I'm going to have to transfer, because otherwise I would be losing the product. Adding some DI water and transfer. time, the brown color is gone, and we have a light yellow color here. Okay. Very light yellow color. Okay, can continue the experiment. Okay, go back to station and continue the experiment. Okay, for second part of the experiment, or to separate the zinc from the excess zinc or unreacted zinc from zinc iodide, I'm going to decant the solution portion of it into second evaporating dish. We have the mass of this already recorded for you. So I'm going to decant this into decanting, meaning just pouring off the liquid or the pouring off the liquid. When you have a mixture of solid and liquid, decanting, meaning you pour off the liquid without getting any solid, okay? Without getting any solid into the receiving container, which in this case is my second evaporating dish. I'm adding more water and washing it. Just want to make sure that there is no leftover of the salt with the zinc. And make sure all the liquid is transferred without getting any solid. And I wash the zinc with the eye water. Okay, when you get to read this experiment before you actually watch the video, you know the next step is for me to get the zinc or excess of zinc dry. So when it's dry, I can measure the mass. To dry the zinc, we are using heating lamp. So I'm placing my evaporating dish under the heating lamp here. Going to turn on the heating lamp and place the evaporating dish under the heating lamp until it's dry. When it's dry, when I try to move the zinc, the zinc particle is going to move around. When it's wet, the zinc particles are kind of clumped together and they are not moving around. That is the last step for part one of the experiment, because we want to get the mass of the unreacted zinc. So we are waiting for that. And while we're waiting for that one, I'm going to go ahead and start part two of the experiment. In part two of the experiment, we need the mass of empty evaporating dish, which I have it as a part 2A, 45.981. That's the mass of empty evaporating dish. We get the solution into the evaporating dish, and with the solution that we have in the evaporating dish, it needs to be vaporized. The solvent needs to be vaporized. So this solution is solution of zinc iodide. When we evaporate the water part, the solvent, we are going to end up with the powdered or solid zinc iodide. The heating must be gentle. We don't want to get any of the water, the solution which contains salt to spatter out of the evaporating dish. So I monitor the boiling. When I monitor the boiling part of this, is going to show me, if it's like gentle boiling, I'm fine with it. If it's not gentle boiling, if it's like boiling very harsh and big bubbles, the chance for spattering of the solution out of the container, I'm going to remove the flame and remove it and move it back and forth in order to give like gentle boiling. So I do need gentle boiling for this evaporation because I don't want to lose any of the product. So going to wait for now and make sure that it starts boiling. And when it is boiling, it has to be gentle boiling. Okay. So we have two procedures taking place, two steps of the procedure taking place at once. The drying of the zinc, unreacted zinc. So we want to know how much of the zinc was reacted. We have initial mass for initial mass for the zinc, whatever we start with, 0.5 grams. And if we get the mass of unreacted, we subtract from initial mass, and this way we can get the mass of reacted. We also have the mass for reacted iodine because we have the mass before and after for the test tube when we had the iodine and we had empty mass for empty test tube container. So if you have the mass of the elements, we can calculate the empirical formula using periodic table, changing the mass of each element to moles, and then dividing by a smaller number to get the mole or a lowest ratio. And if it's not whole number, we have to treat in order to get whole number. So if you get like a 0.5, you multiply by 2 to get a whole number. If you get 0.33 for one of them, you multiply by 3 to get the whole number. So you have to treat number. By the time you do this experiment, or you have to write a report or data sheet for this experiment, lecture portion of the class, you will learn about the lecture. Your lab professor, if it's me or anybody else, is going to also have a meeting with you, a short meeting with you to explain about the theory of the experiment. So hopefully, and you read the experiment, the theory part of the experiment from the lab manual carefully in order to understand how to do the calculation as well. Okay, I have student office going to just let her know. Okay. Let's see if the zinc, the unreacted zinc, has been dried. And if it's been dried, okay, the zinc particles are moving around, but not all of it. So to be safer, I probably have to wait longer to make sure that it's completely dry. Maybe just 2 more minutes. I don't want to lose any zinc particle because I touched the zinc with the stirring rod. I have to get the pieces, make sure the pieces are back into the container, into the evaporating dish. Because the error for mass here and there can add up. And when it does add up, your numbers are not going to look nice. Well, the numbers are not going to be perfect numbers because these are not made up numbers. These are the real numbers that is called actual. You have actual numbers and then you have theoretical values. The difference between actual and theoretical values in experiment is called experimental error or percent error. Some range of percent error is acceptable in a experiment. So that percentage of error, the acceptable range, it depends on the experiment, what type of experiment we are doing, what's the rate, or if the, for example, chemical reaction reaches equilibrium, it doesn't reach equilibrium. And it also depends on the error caused by human error, caused by person who's performing the experiment. So we don't expect 100% always percent yield or 0% error, but there's some sort of a acceptable range. And for that acceptable range, it's going to be different from one experiment to another experiment. I'm not going to give a number to you because then it can cause, uh, expectation for students. Um, but it depends on your professor who's teaching what is the number that they are going to expect. But it's not 100% always. Okay, the zinc, perfect. Unreacted zinc is, I'm going to show it to you actually what I mean by, you see, the zinc is moving around. And if it's moving around, that means it's not moist, because when it was moist, it was stuck to the wall because it was moist. Now it's moving around and it shows that it is dry. So I'm going to turn off the heating lamp at this point. Wait for the for evaporating dish to cool down to room temperature, and weigh the container, which is the evaporating dish plus unreacted zinc. Also, I want to show you what I mean by the gentle boiling. If you can see the boiling there, is the gentle boiling. Is not crazy, is not spagging, and is not moving the chemicals out. Can measure the mass of the zinc. The balance needs to be there. The unreacted zinc. This is for part 1 of the experiment. And it's going to go to part E for part 1. So if I don't say it's part 2, it's part of the part 1, but since I already brought part 1 into the data part, I'm going to specify part 1, letter E, and the mass is 40.642. 40.642 grams. This is the mass of, you can use this to find the mass of unreacted zinc. Perfect. One last part to the experiment is we have to wait for this solution to dry out completely before we can measure the mass. There are some questions, like additional questions. You can answer those questions. Basically, it's like calculation with hypothetical numbers. Or you could also ask the professor who's teaching the lab, if you need any clarification. I cannot give you the answer at this point, because if I give you the answer, then there's really nothing for you to do, because I did the experiment. So the experiment, these questions are straightforward. They are not very complicated. So it's going to tell you what to do to answer those questions. Like writing a balanced equation. Like if you have zinc plus I2, what would be the product? But the part of the experiment which I understand, as a remote learner, you are not going to be able to come to the lab to perform the experiment, to collect the data. I do that part of the experiment for you, to give you the data so you don't have to be here for this time. Going to start. I need to do for the second half of the experiment. This one part of the experiment, I missed it for experiment 2. When I was recording experiment 2, I'm going to have to perform that experiment today. Getting this ready. The hottest part of the flame, since we have time, I'll show you some more techniques. The hottest part of the flame is the top of the inner cone right here. Top of the inner cone, that's the hottest part of the flame. If you go down or you go up, it's not going to, the temperature actually drops. The hottest part is the top of the inner cone. So if you adjust the container or where you're heating up the level that it touches the top of the inner cone, you are providing the highest temperature of the flame. And if you want like cool flame, you have to make it more distant. Definitely no yellow color flame, because yellow color flame has low temperature but is not a safe flame to work with. Just gonna give time, and at this point, if I have low flame is better, and it's gonna give maybe 2-3 minutes time, it will finish. Just gonna give time for it. Okay, so you probably want to know what's going on. Almost there, and it just needs maybe like a couple more minutes to dry up completely. When it gets low, drying out, it happens like quickly because that's very concentrated at this point, because you have all of your zinc iodide in that small volume of solvent. So it's very concentrated. It's a thick solution at this point. But now 2 minutes, right? So estimated. It's just such a small volume. It could be the problem could be the concentration is very high. Almost there, almost. Okay. See it for yourself. Almost there. The water is gone. It's dry. If I continue heating, I'm going to lose the powder. So I'm going to stop and lift it up for like much more gentle heating. You don't want the color to change. Color should stay white color as it is. But you want to make sure all the water has been evaporated. Okay, done. So we turn off the Bunsen burner. We leave the evaporating dish. To cool down to room temperature before we measure the mass. When you are measuring the mass, you should always measure the mass at room temperature. So to be consistent, we have to measure the mass at room temperature. So I'm leaving on the wire gauze, wait until it cools down to room temperature. The same thing again, I'm going to close my hand. If I don't feel the radiation of the heat, it's good enough for me to measure, but I still feel it would be a while because it's dry. There is no liquid. If we had like a hot water, because of the specific heat that water has, it takes longer for it to lose the heat. But for solid clay like this, with the it doesn't have a much. It doesn't have a high specific heat. As a result, it can actually change the temperature. The temperature of the object itself is going to go up and down quickly, so it can reach the room temperature quick. It doesn't take that long. I guess you learn about that in the general chemistry or beginning of general chemistry too. Okay, we measure the mass of evaporating dish with the zinc iodide, and that goes into part 2. That goes into part 2 plus dry B, which is the dry product. So part 2B. And the mass is 46.508. 46.50 is changing, so 8. And that is gram. That's for part B. For part C is asking for color of the zinc iodide powder, which is a white powder, white solid or white powder. And that should go to part C of the data sheet. Everything else, you do have like mass of the zinc iodide, which you actually need to do the calculation based on the information that you have. But the information to be collected in the lab are those numbers that I already typed in the chat area. Also, I said it, so you can record those numbers. And also the description of the appearance, just because it's a white powder I showed you, so you can record your observation based on the observation, or it's white powder. That's what you have. Okay, we are done with experiment 3. I'm going to stop the recording here. Again, you might, if you have any questions, I'm sure your professor is going to, if it's me or anybody else, is going to explain using the classroom chat or Blackboard. Thank you.